got it. Okay, so if you remember when we did absolute value equations, there were two scenarios. Either what's inside the absolute value was positive or negative, and then that meant a couple different things can happen. As soon as we compare, you don't have to write anything down from this slide. As soon as we compare an absolute value to an inequality symbol, less than, greater than, there's really two scenarios that are going to happen. Remember, absolute value means distance from 0, okay? So if we say the distance from 0 is less than 3, that means it could be between -3 and +3. And this is what we get when we see an and statement a lot of times, right? When we graph those inequalities, it's where they overlap, it's where they intersect. If we're talking about distance from 0 being greater than a specific number, then it's either above 3 or below -3. And this is really what we see if there's an or statement in an inequality, where they're going two different directions and they don't necessarily intersect. So if it's less than, we use an less than we use an and, greater than we use an or. And a good way to remember that is on the next slide. You want to write this down, the word goal at the bottom there. Okay, so greater than, we're going to use an or statement. Less than, we're going to use an and statement. Now, all this stuff at the top, this is out of your textbook. If you really want to look it up, you can. I don't use this when I split my inequalities into the two pieces. Like our equations, we're going to split our inequality and compare it to a positive number and compare it to a negative number. When we change the sign, though, in an inequality, what's going to happen is my inequality sign is going to flip also, because we're multiplying by a negative, essentially, when we're changing the sign of something. And then we're going to use the word goal to help us to remember then with the two pieces, are we going to put an or an and symbol between them? And then with that, we're going to solve it like we did a couple days ago. Okay, so you'll kind of get the hang of this, how these are split as we go. Okay, oops, wrong way. There we go. All right, so let's try a problem. Let's see what these look like. So absolute value of x plus 5 is greater than or equal to 7. So like our equations, we're going to start by getting the absolute value alone. So in this problem, I just need to move the 5 over and make it a 2. Okay, so the absolute value is greater than or equal to 2. Remember, this means distance from 0 is greater than or equal to 2. So you can maybe start picturing what our answer is going to look like. Now, mathematically, here's how we're going to solve it. We're going to split it into the two pieces. We're going to say either what's inside my absolute value is always going to stay the same. X is greater than or equal to 2. So exactly what I see in my equation, but without the absolute value bars. And then in the other one, I'm going to compare it to -2. But when I put a negative there, I've essentially multiplied by a negative. And when we have an inequality and we multiply by a negative, the sign flips. So in that second one, you're going to change your inequality sign. And then we use the word goal to help us to remember, are we going to connect these with an or an and? So because I had a greater than symbol, I'm going to use the word or when I connect my two pieces. And if you need to solve for x, you would do it at this point. There's nothing to solve for. X is already isolated. This is our answer in inequality form. Then we're going to graph it like we've practiced. Because it's equal to, we use brackets. If it's not equal to, remember we use parentheses. So greater than 2. Oop, I said bracket and I made a parentheses. Don't do that. There we go. 4 less than or equal to -2 looks like that. Okay, again, distance is more than 2. All right, and then in interval notation, that would be -∞ to -2, union symbol to infinity. Okay. Any questions on that problem? Make sense what we're doing? I'm just going to practice this today. All right, let's try another one. Absolute value of x minus 4 is less than 1. Absolute value of x minus 4 is less than 1. Is my absolute value alone? Yes, there's nothing added, subtracted, multiplied, or divided by that absolute value. Now, there's stuff inside it. My x isn't alone, but the absolute value itself is alone. So we're good to go ahead and split it into two pieces. Okay, so the first one's going to look the same as my original inequality, just without the absolute value bars. In the other one, instead of a 1, I'm going to use a -1, and I'm also going to flip my sign then. Would I use a and or to connect these two pieces? What do you think? Yep, this is a less than. My absolute value is less than 1. So less than tells me to use an and to connect the two. All right, and this is like what we did on Friday last week. So we're going to solve each of these individually. In both of them, I just add 5. So, or add 4 to get 5 for this one. X less than 5. And if I add 4 over here, I get 3. Graphing it. Both of these are going to be parentheses because they're not equal to. So less than 5 would look like this. Greater than 3 would look like this. It's an and statement, so we're looking for the intersection, or the part that got shaded twice. My intersection is between the two numbers, so 3 to 5 with parentheses is my solution. Okay. Yep.
So when we write the squiggly lines and stuff for the test, will we get points off if it doesn't go past the brackets, or is it okay?
I don't think on the test this is part of the answer line at all. This is just part of your work. So no, I wouldn't mark that wrong. Okay. You can check this answer too. You can pick a number in this range. Like if I pick 4, plug it back in, make sure I get a true statement when I plug it back in. So that's always something, if you have extra time, you can kind of spot check it a little bit. All right, let's try another one. 5 minus 2x, and so my absolute value of ours is greater than 3. Okay, absolute value is alone. Nothing added, subtracted, multiplied, or divided by it. So we're ready to split it into our two pieces. So 5 minus 2x is either greater than 3, same as my original problem. My other one, 5 minus 2x. This time I'm going to compare it to a negative 3, multiply by that negative, and my sign flips. Am I going to use and or? Or. My absolute value is greater than, so we use an or to connect the two. All right, what's my first step to solve both of these mini equations now? Subtract 5, so negative 2x is greater than negative 2 on this one, and negative 2x is less than negative 8 on that one. Next step. Yep, and if I divide by a negative, what's going to happen? Sign flips again. All right, so now it's going to be x less than 1 or x greater than 4. Not equal to, so I'm using parentheses. Less than 1, shade below it, greater than 4, shade above it, or it's just whatever shaded is my answer. Only if it's an and are we worried about if they intersect or not. So my answer is negative infinity to 1. Everything's going to have a parentheses. 4 to infinity. Questions there? Okay. I'm going to jump around here a little bit. I'm going to come back to these fraction ones. We have two special cases of this. What is different about these two equations than all the or inequalities than the ones we just did? What's different about these two? There's a negative on the other side, okay? And if it was an equation, can an absolute value ever be equal to a negative? So when we saw the equations, we automatically said no solution. But now we're talking about, is whatever's inside that absolute value greater than or less than something? So it might be a no solution, but it might not. So here's how you know. Okay, so whatever's inside an absolute value, here it's 5x plus 1, is positive, right? Or 0, or equal to 0. And on the other side, I have a negative number. When is a positive number, or 0, greater than a negative number? Always. This equation, inequality, is always true. So if it's always true, what is my answer? All real numbers, negative infinity to positive infinity. Okay. Look at the other one. When is an absolute value, which is positive or 0, less than a negative number? Is that ever going to be less than or equal to negative 2? No, never. So this is where we would get empty set, no solution. Okay, so if you see the negative number there, stop. It's one of these two special cases. If it's greater than, it's going to be all real numbers. If it's less than or equal to, it's going to be never. Make sense? Okay, last two questions. So now what happens if I have a rational absolute value inequality? I love this problem because it puts like everything we've done for the last 5 days all together in one question. Okay, so starting out, my absolute value is alone. There's nothing added, subtracted, multiplied, or divided by it. So we're going to split into the two pieces. Either, I need a different color, it's not going to show up. There we go. X plus 3 over x minus 2 is greater than or equal to 3. My other one, either x plus 3 over x minus 2. This time I'm comparing it to a negative 3, so I flip my inequality sign. Am I going to use or and? I'm going to use greater than, so I'm going to use the word or. Okay, now each of these we're going to solve like we did yesterday. So yesterday we wanted our rational expression to be compared to 0, which these are not. So I'm going to start with the one on the left. I'm going to move that 3 over. X plus 3 over x minus 2 minus 3 is greater than or equal to 0. And then do you remember what we did next after we got it compared to 0? Yesterday, the very last problem we did yesterday was like this. Kind of, sort of. We got a common denominator, so that's a negative 3 over 1. Common denominator is x minus 2. So I'm going to multiply the top by x minus 2 and the bottom by x minus 2. All right, so that's going to look like my denominator is just going to be x minus 2 when I put them together. I'll just do it all at once here. In the numerator, I'll bring down what I have. From the first fraction, I have an x plus 3. In the second fraction, we have a negative 3 times x minus 2. So I'm going to distribute that negative 3 in. So it'll be a negative 3x plus 6, greater than or equal to 0. And then combine my like terms. So now I have negative 2x plus 9 on top over x minus 2 greater than or equal to 0. Okay, yesterday we factored if we needed to. We do not have to factor here because the numerator and denominator are already linear. So you can just set the numerator and denominator equal to 0 to find our breaking points. If I set my numerator equal to 0, I'm going to get x is what? I would have to subtract 9, divide by negative 2. What's that going to give me? Positive 4.5. Yeah, you could just say 4.5 or 9/2. If I set the bottom equal to 0, I get x equals 2, but it's a not equal to, right? Because that's a domain restriction. Then yesterday, we did our number line. 2 and 4.5. And we're just plugging it in where it's compared to 0. And remember, all we care about in each of these intervals is it positive or negative? Let's say I plug in 0 from over this. Here, this would be an easy one, right? If I plug in 0, the top would be positive. The bottom would be negative. So a positive divided by a negative is negative. Okay. Let's say I plug 3 in for this middle section. I would get a positive on top, and I would get a positive on the bottom. So it would be positive. Let's say I plug 5 in from over here. That would be a negative 1 on top, and it would be a positive 3 on the bottom. A negative divided by a positive is a negative. Do I want the positives or negatives? I want it to be greater than or equal to 0. So the positives are my answer. So that half of the problem has answers between 2 and 4.5. I follow the inequality sign. That tells me to use a bracket, except at 2, because that's a domain restriction. Parentheses at 2, bracket at 4.5. Then we bring down our or, and we do it again for the second half of the problem. Go ahead. You do the second half. Use this one as a guide if you need to. Such a good problem. you get 3/4 to 2? Bracket at 3/4, parentheses at 2? Okay, last step now is put them together. In an or statement, do we care if these intersect or not? No, it's just both pieces put together. If this was an and statement, by the way, nothing intersects between these two. The answer would be no solution. But because it's an or statement, my answer is going to be from left to right, and you can graph it on the number line if you need to. 3/4 to 2. We jump over 2 because that's a domain restriction in both of these and in the original problem. And then 2 to 4.5. Final answer. Yes?
Why do we only do like the inside part of that second one instead of like -3?
Because this one, the inequality symbol is different. Over here, it was greater than, so we use the plus. Here, it's less than, so we're looking for the minuses. Good question. Okay, anything else on this problem? All right, last question. We're not going to go through the whole thing because it's really similar to what we just did. I just want to show you the first step is a little different. If you see absolute values on both sides like this, the first thing you're going to do is get them both on the same side compared to a number. So in this problem, I would have to divide by the absolute value of x minus 1. So when I have an absolute value of something over an absolute value of something, I can just take an absolute value of the whole thing, like this, less than 3. And then it looks like the problem we just did, okay? But there's an extra step at the beginning if you don't have it set up like that already, okay? All right, and that's it for absolute value rational inequalities. Okay, so I'm going to give you back tests. You guys can work on Math Excel now if you want. Your Math Excel is due tomorrow night. Does that sound right? Sound right? Yes. Yes, due the 16th. Okay, so you've got Math Excel due tomorrow night. You've got almost a half hour in class to work on it now if you want to. I'm going to pass back tests. Let me know if you have questions on your tests. Do not keep your tests. They need to go back in the tray when you're done looking at them. I'm also going to give you guys the test review that we're going to go through together in class tomorrow. You absolutely do not have to do it, but if there are those of you that want to try it on your own first, like a practice test, and then just check your answers as we go through it in class, that way you know what you want to practice more of on your own, you can do that, because the test over this stuff is on Thursday, and it's just a one-day test, so it's coming up kind of quick. So I'll get you that review in a minute here, too, so you can have it. Just make sure you bring it back to class tomorrow to go through it together. Any questions on any of that? All right, go ahead and get started. I'll do cell phone lotto for you.